to solve another Leetcode problem, 861, score after flipping matrix. So this is a matrix problem. So we are giving a matrix. Inside the matrix, there will be binary numbers. And what we can do, we can flip rows and columns as much as we can. Yeah, it means there's no limit. So we can flip as many rows as we can, and we can flip as many columns as we can, or we can flip after one row and after one column, and we can, yeah, continue do this kind of a flip operation. So let me first go to the whiteboard to explain the problem. So if we are giving a matrix, inside the matrix, inside there will be numbers. So we don't know. Maybe the numbers is 0, 1, 0, 1, and some other numbers. Yeah, we just don't know. Yeah, we just don't know if it is zeros or ones, but it doesn't matter. But what the problem asks is to get the maximum result by the binary representation of each row. So for example, for each of the row, if it is 1, 1, 1, 1, 1, yeah, it must be the maximum number. Yeah, so this is in the realistic situations, if it always be 1. But for other situations, it is not like that. So each of the numbers, it can be 0 or can be 1. Yeah. So for example, this area is, we are not sure. Yeah, so if this first columns, we are sure it is 0, 1, 0, 1. Yeah, just use this example to explain the situation. So if it is like this, we will ignore all other numbers. If there will be no influence for all the other numbers, we only consider the first rows. So what we can do to make the number maximum, because this is the highest bit. Yeah, for example, this is a bit 5 and this is a bit 1. So for a binary representation, so this column, so the column 0, it must be the maximum. Yeah, so this column 0, it must be the maximum result. So what we can do to make this column as big as possible? So we want to turn these zeros to 1. Yeah, because after 1, it can be any kind of a binary numbers, but it doesn't matter. But this row must be the maximum. And this 0, if we turn it into 1, so this row must be the maximum. Yeah, we can prove it by the else situation. Yeah, so if it is not like this, so if it is this column, the first column is not always be 1. Maybe this is a 0, this is 1, this is a 0, this is 1. So this result must be smaller than this result. Why? Because first column, if it is always 1, even it is a 0, yeah, it doesn't matter. So this area is always be 0. It doesn't matter. Yeah. But for this one, after it, even it is always be 1, it is still the smaller than the above. Yeah, we can compare like this. So 0, 1, 0, 1. So even after it, it always be 1. It doesn't matter. Yeah, because this number, the sum of these numbers will always be bigger than these areas. Yeah. So this is the first step we can do. So this is why it is a greedy problem. So first, what we can do, we're gonna turn the first column numbers to 1. So let me just delete these areas. Yeah, I don't know how. Let me remove these areas. Yeah, maybe I can remove like this. So let me remove these areas. Yeah, so this means in these areas, if we keep it always be 1, it must be the maximum number for the first column. So after that, we can ignore the first column. We will only consider after the first column. So what gonna be after the first column? Yeah. So the first column will always be 1. It doesn't matter because it's already be the maximum. But how did we get the first column always be 1? We did the row operation. Yeah, we did this row operation and this row operation. It doesn't matter. Yeah. So the first step is to do the row operation to make the first column to be always 1. But after that, the numbers can be any kind. It can be 0, 0, 1, 0, or it can be 1, 1, 0, 0, or it can be 1, 1, 1, 1, or it can be 1, 0, 1, 1. But what we need to do after that, we need to keep the columns as many ones as possible, because after that we will not do the row operation. The row operation has been finished. If we do the row operation, it's gonna change this to 0. So we don't want to change all these numbers to 0. So we're gonna do the column operation. So if we want to do the second column operation, what we can do? Because there are more zeros than ones, there are 3 zeros, only 1, 1. So what we can do? We're gonna turn these zeros to 1, and turn this 1 to 0, and turn this 0 to 1. So after that, you can say the numbers will be bigger. Yeah. And how can we check it? We're just gonna check how many rows. So there are 4 rows, and how many zeros inside, or how many ones inside. So we're gonna check how many zeros inside. So if there are we're gonna check how many ones inside. It's the same. If there's only 1 inside, 1 times 2 is less than the number of those. So we're gonna do a flip. Yeah, we're gonna do a flip of the column. Yeah, and here this operation we call it flip of the rows, and here just flip of the columns. Yeah. So this is a flip row, and this is a flip column. And we're gonna do all the operations like this. So for example, this one, we're gonna keep it. This one, we're gonna keep it because there are more ones. And this is also the same. There are more ones, 3 ones and 1 0. So after that, this will be the result. We just get the result row by row and turn the binary representations to the final result and sum all of them. Yeah. Now let me go to the code editor to finish the coding. So as I explained, we're gonna do the greedy operation. So the first one will be the greedy of the first column, and then I will greedy of I do the greedy of the first column by the row operation, and then I do greedy from the second to the last column by the column operation. Yeah. So let me first define 2 functions. I'm gonna call it flip row, and I will give a path, and then I will define another operation. I will call it flip column. Yeah. So inside I will give a row because I will do the operations in place. Yeah, I will do the operations in place just inside the grid. I will not use actual memories. So for the column operation, I will also need a column. Yeah. And I also need a function to check the result. So I'm gonna use a check val. Yeah, I'm gonna check the I will define a check rows. I will check each of the results. So inside it will be a nums, and I will give a pass at the moment. Yeah. Now I want to finish the operations. So first I will do the greedy operation for the first column. So for the first column, I will do the row operation. So what I can do, I just use a for loop. So for C, because it is the first column, so I will do for R in read capital R. So before that, I will define 2 variables with capital R and capital C with the rows and columns. Yeah. So length of the grid and length of the grid 0. Now I want to do the first column operation. So for the first column, if I wanted to turn all of them to be ones, I needed to do the row operation. Yeah. So for each of the rows, I will check. Inside each of the rows, I will check if grid row 0. This means the first column. Yeah. If inside the first column, if I find a number that is 0, So if grid R0 equals to 0, what I needed to do, I needed to do the flip operation. I needed to do the flip of the row, and I will give a column. Yeah, because I will do the flip row for each of the column. Yeah, for this row, I will flip it. Yeah, for example. And now I will do the second operation. So for the second operation, I already finished the first column. I will start from the second column. So for R in, yeah, let me check. So for the second column, I needed to do the row operation, right? Yeah. So I will gonna use the column. So for C in range 1 to capital C, I will do the column operation, but I need to check. So for grade, yeah, I think it's still, yeah, yeah, I got confused. I solved it just a moment ago. It goes very fluently, but for the matrix, I have to think about it. Yeah, so for the column, if for each of the column, I needed to do the column operation. So yeah, it's still the same for R in raise 1 to capital. Yeah, I think it's the same. For C in 1 to for C in raise 1 to capital C, I needed to do the column operation. I needed to check if the yes, for here I think I needed to check each of the column. Yeah, so for here, for each of the column, I needed to check the values of the column. Yeah, I needed to check the ones inside this column. So currently this column is fixed. So this is column 1. I needed to check the sum of the ones. So if sum of all the columns, yeah. So if sum, I will use a grid. If sum of the grid are C, so here I will grid RC for R in range. So I will gonna use yeah. So for R in range with a capital R, so it will start from the row 0 to row R minus 1. Yeah. So if sum of them is times 2, it's less than the number of those R. So what I needed to do, I needed to flip the column. So inside I will give a column. Yeah. After I finished the flip row and column, I can get the result. So I need to get the result. So the result is the sum of check row with row for row inside the grid. Yeah. Now what I need to do, I need to finish these 3 functions. As you can see, these 3 functions is not so difficult, right? Let's first finish the check row because this will be the easiest. So I'm gonna return. Let's say I will use integer. Yeah, I will turn the string into nums. Yeah, basically I can do the bit operation, but just for saving the time, I'm gonna use the int. Yeah, I'm gonna turn the string into int. So empty string dot join array. So inside I will give a number, turn this number into string. So for n in nums, and this is a binary number, so I give a 2. So after that, I will turn this binary number into an integer. The base of the integer will be 10. So here I will give a 2. So after that, the base will be 10. Yeah, because this is base 2. Now I need to finish the flip row and flip column. Yeah. So for flip of the rows, so this is actually each of the rows. I just need to check each of the rows to flip it. So this is gonna be easy. So it's gonna be the row is fixed, right? So we just need to check the columns. So for C, in range capital C, the grade RC should equal to 1 minus grade RC. Yeah, because the row is fixed, we just need to check all the columns. Yeah. So for this one, we just need to flip the column. So for flipping the column, I just need to check all the rows because the column is fixed. So for R in range capital R, so grade RC should equal to, this is equal, not double equal. So it should be equal to 1 minus grade RC. So this is just a flip, and this is a flipper. Yeah. Each of the column, for example, the column is 1, so it is this column. So I'm gonna check all the rows and I'm gonna flip it. Yeah. I think this is basically all the functions. It's not so difficult, but the difficult part is the greedy idea. How you can prove it must be turn the first column always be 1, and then you're gonna keep other columns as many ones as possible. Yeah, except the first. Yeah, because the first column has already been ones. Yeah, and for the second, you're gonna turn as much ones as possible, and also for others. Yeah, if you can check from this example, actually this is the idea of the first operation to the rows, and then the other operations to the columns. If you can find some intuition from this example, maybe you can also solve the problem. Yeah. Now let me run it to check if there are any mistakes. Yeah, there's this kind of mistake. Let me see. Yeah, I did some typos. So this is a grade. Yeah. Let me run it to check if it works. So this is a flip row. Local variable C. Yeah, this is because this is a flip row. Actually, I need to give a row. Yeah, I think it should be a row because this is just a flip of the rows. Any of the rows can be flipped. Yeah, as you can see, it works. Let me now submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and the speed is okay. Yeah, now let's just check the time complexity. Yeah, because this m and n is a very small number, it is a 20. Yeah, so that is why it is so fast. Yeah, now let's just check the operations for here. So for the rows, this is an operation, it is just on. Yeah, if we think m equals to n, so this is the on operation, and this flip is just the on operation, so this is n square. And similarly, let's check here. So this is on, and here this is another on, and this flip column is another on. So this is n cubic. Yeah, and let's check the final result. Yeah, so for the check row, let's check the check row. It is just on operation, and for each row, it is another n operation. So this is also n square, but the maximum will be here. It is n cubic. But for n cubic, 20 cubic is also a very small number. It is just 6,000. So that is why the time complexity is n cubic. Thank you for watching. See you next time.